You're resting peacefully, perhaps feeling the soft weight of a cozy blanket, or the gentle, rhythmic motion of your own breathing. As the world outside begins to hush its busy sounds, a familiar thought might settle gently in your mind, the quiet, intricate dance of something appearing, and then, just as subtly, vanishing. Perhaps you've watched a delicate leaf detach from a branch, fluttering gracefully for a moment before disappearing into a distant stream, its presence absorbed by the flowing water. Or maybe you've observed a wisp of morning mist, shimmering softly in the dawn light, only to dissolve silently into the vast, open air. These everyday occurrences, these gentle disappearances, spark a quiet wonder, don't they? They hint at a world where things can cease to be, or simply move beyond our sight. Tonight, we'll gently ponder a profound and perhaps whimsical question, letting our thoughts drift to the concept of teleportation, the idea of instantaneous movement, asking could a familiar object, or even you yourself, truly vanish from one place and reappear in another, as if in a beautiful, fleeting dream, challenging the very essence of how we understand presence and distance. We often encounter the idea of teleportation in our stories and dreams, a magical leap through space, defying the everyday rules of travel. Imagine stepping into a shimmering beam of light and, in the blink of an eye, finding yourself effortlessly transported across vast distances without traversing the space in between. This concept feels so liberating, so wondrously efficient, promising a world where journeys are measured not in miles or hours, but in moments of pure, instantaneous presence. This immediate connection to the idea of effortless movement seems so fundamentally clear, so absolutely desirable. But if you allow your thoughts to linger, to softly trace the edges of this whimsical certainty, you'll find that the very act of existing, the way objects maintain their form and identity, is far more intricate, far more beautifully orchestrated than a simple switch from here to there. It's a master weaver, tirelessly holding countless threads of information together, ensuring that every detail, every subtle nuance of an object's being is perfectly maintained. Imagine, if you will, that ceramic mug resting gently on your bedside table. It feels solid, stable, perfectly defined in its space. Its color is distinct, its texture smooth, its very essence tangible. In our familiar world, if you want to move that mug from your table to the kitchen, you must physically carry it, traversing every inch of space between the two locations. It occupies every point along that path, continuously existing in one place after another. This seemingly simple act of movement is a profound demonstration of the laws of physics that govern our everyday world. Laws that dictate the continuous presence of an object through space and time, but the idea of teleportation challenges this fundamental notion of continuous presence. It suggests a leap, a discontinuity, for something to truly disappear from one spot and instantly reappear in another. It would, in essence, need to be disassembled in one place and reassembled in another. Or perhaps, its very essence would need to somehow tunnel through the fabric of space itself without occupying the intervening points. This immediately brings us to the profound realization that at the heart of any teleportation, whether real or imagined, lies a concept even more fundamental than movement, the intricate nature of information. Consider that ceramic mug again. What makes it that mug, and not just a collection of atoms? It's not just the atoms themselves, but the precise, intricate arrangement of those atoms, the specific way they are bonded together, the exact crystalline structure of the ceramic, the subtle patterns in its glaze, The unique imperfections that make it yours, all of this is information. It's a vast, complex blueprint, a cosmic symphony of atomic positions and energies, precisely defining its existence. For the mug to reappear perfectly in your kitchen, every single atom, every single molecule, must be precisely replicated in its original location, orientation, and energy state. This requires an unimaginable amount of information to be perfectly, instantaneously transmitted and recreated. This profound challenge of information is essential for your very sense of self. If your brain presented you with a world where objects randomly vanished and reappeared, or where their fundamental properties subtly shifted with each appearance, the world would feel disorienting, disjointed, and profoundly confusing. Your brain, in its infinite wisdom and profound kindness, gently relies on the stability and continuity of objects to craft a stable, predictable, and meaningful reality that allows you to navigate the world with effortless grace and a sense of comforting familiarity. The very idea of teleportation, when deeply contemplated, touches upon the most fundamental principles of what it means for something to exist, to have identity, and to move through the fabric of space and time. This constant act of understanding, this subtle orchestration of reality, is not about dismissing the wondrous. No, your scientific curiosity is not trying to trick you in a harmful way. Rather, it's a supremely efficient and highly adaptive system, tirelessly trying to make the most sense of the world, to predict what's coming next, and to ensure your safety, comfort, and well-being. In its tireless effort to achieve this profound goal, it seeks continuity and order. And the idea of teleportation, while captivating, quietly prompts us to consider the immense, delicate challenge of perfectly replicating every single piece of information that makes an object, or a person, uniquely themselves. The very speed at which your brain comprehends the idea of instantaneous movement is astonishing. In the blink of an eye, in a fleeting moment that seems timeless, you can imagine a leap across vast distances. But then, as you gently linger, the profound complexities of what that truly entails begin to unfold the vast number of atoms in a single mug, the intricate details of their arrangement, the seemingly impossible task of perfectly recreating them elsewhere. This effortless conceptualization, followed by a gentle realization of its physical challenge, occurs continuously, ceaselessly, even as you quietly rest, ensuring that the moment you gently awaken, the world is already there, perfectly formed, and ready for your gentle interaction, its continuity beautifully preserved. A general historical fact that highlights this wondrous process. For centuries, the concept of matter being made of tiny, fundamental, indivisible particles atoms was a philosophical idea, debated by thinkers like Democritus. It was only with the advent of modern chemistry and physics in the 18th and 19th centuries that the atomic theory gained strong scientific footing. Revealing the universe is indeed built from countless tiny, intricate units, making the concept of perfectly replicating them a monumental task. Here's a lesser-known detail about the subtle information of objects. Even the smallest macroscopic object, like a grain of sand, contains an astronomical number of atoms. To perfectly specify the exact position, momentum, and quantum state of every single atom in that grain of sand would require an amount of information so vast that it would dwarf all the data ever recorded by humanity, stored on all computers in the world. This gives a gentle sense of the immense informational challenge involved in teleporting even a tiny object, let alone something as complex as a human being. It's like trying to perfectly copy every single grain of sand on a vast, endless beach. And for an ongoing academic debate, physicists are still actively researching the fundamental nature of information in the universe. Is information truly conserved at all times, even in extreme events like black hole formation, or can it be subtly lost or irretrievably scrambled? Understanding the ultimate fate and behavior of information is crucial for comprehending the true limits of physical processes, including the theoretical possibility of teleportation. The intricate interplay of these concepts remains a fascinating and complex area of study, revealing the subtle wisdom of our universe's fundamental laws and its profound, sometimes hidden, artistry in managing information. So, as you continue to relax, allow your mind to gently contemplate the quiet whisper of disappearance and reappearance, that familiar sense of witnessing something vanish. Feel the profound peace that comes from understanding that the very essence of an object, its unique identity, is woven into the intricate information of its countless atoms and their precise arrangement. Let this understanding cradle your consciousness, like the serene, unwavering rhythm of a gentle narrative, as you gently surrender to the peaceful, restorative depths of slumber. The quiet artistry of existence, holding every detail in place, is now your lullaby, a soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, forever shaping the world you gently experience, and inviting you to dream of all the profound ways things exist. You're floating deeper now, gently carried by the quiet understanding that the familiar world, at its tiniest scale, is a shimmering dance of probabilities, not solid certainties. As you drift, let's explore the very heart of this profound mystery, how these fundamental particles, the smallest whispers of existence, behave not like tiny defined marbles, but like elusive, ethereal mists, perpetually in motion, simultaneously existing in a wondrous state of graceful uncertainty. This is the serene essence of the silent flow of the smallest particles, where an electron, a photon, or a quark is described not by a fixed location, but as a probability, a delicate, shifting cloud of potential, always in elegant, uncertain movement. In our everyday world, when you hold a pebble in your hand, you know precisely where that pebble is. If you toss it gently, you can predict, with remarkable accuracy, where it will land and how fast it will be moving. These are the familiar rules that govern the macroscopic world you comfortably inhabit, a world where objects have definite positions and predictable trajectories. But when we descend into the unimaginably tiny realm of quantum physics, these intuitive rules gracefully dissolve, revealing a reality that is far more fluid, far more mysterious, and profoundly beautiful. At this most minute scale, particles like electrons, which quietly dance around the nucleus of every atom, or photons, the tiny packets of light that allow you to see, or quarks, the even smaller components that make up the protons and neutrons within the nucleus. These fundamental building blocks of the universe do not behave like miniature, solid marbles. No. Instead, they possess a peculiar and wondrous property. They are best described not by a fixed location or a precise speed, but by a wave function. Imagine this wave function as a beautiful, ethereal cloud of possibilities, a shimmering mist that spreads out across space. This cloud doesn't tell you exactly where the particle is at any given moment. Instead, it tells you all the places the particle could be, all the speeds it could have, each possibility existing with a certain probability. It's like a peaceful, quantum dream, holding countless potential realities within its gentle embrace, waiting for a gentle interaction to reveal one specific outcome. So, when an electron is orbiting an atom, it's not following a tiny defined path like a planet around a star. Instead, it exists as a diffuse probability cloud around the nucleus. It is only when our gentle curiosity, through an act of observation or measurement, interacts with this particle that the wave function seems to collapse. At that moment, and only at that moment, does the particle appear to choose a single, definite state, a specific position, a particular speed, as if the act of looking gently persuades the shimmering mist to condense into a single, concrete reality. This is a profound departure from our everyday experience, where everything seems fixed and certain from the outset. It challenges our intuitive understanding of existence, suggesting that reality at its deepest level is not fundamentally determined, but subtly influenced by observation itself. This concept, often referred to as wave-particle duality, means that these smallest particles behave sometimes like tiny, localized particles when observed, and sometimes like spread out, undulating waves when not observed. It's like a soft, flowing river that can also manifest as individual droplets of water, depending on how you choose to interact with it. This duality explains how light, for instance, can sometimes behave like a stream of particles' photons and at other times like an undulating wave. It's a harmonious dance, a beautiful paradox that underpins all of reality. The sheer unpredictability, or rather, the probabilistic nature of these particles, is what makes the quantum world so mysterious and so fascinating. You can't predict with absolute certainty where a single electron will be at any given moment, but you can predict with astonishing precision the likelihood of finding it in a particular region. This statistical elegance allows quantum physics to make incredibly accurate predictions about the behavior of vast numbers of particles, even if the fate of any single particle remains shrouded in a gentle, inherent uncertainty. A general historical fact that highlights this quiet revolution. The idea of quantum mechanics, particularly wave-particle duality and the probabilistic nature of reality at the subatomic level, was a profound intellectual leap in the early 20th century. Pioneers like Max Planck, Albert Einstein, Niels Bohr, and Erwin Schrödinger, through their quiet contemplations and mathematical insights, bravely ventured into this new, counterintuitive realm, forever changing our understanding of the fundamental nature of matter and energy. Their work, though initially unsettling to some, revealed a deeper, more elegant truth about the universe. Here's a lesser-known detail about these silent movers. Even when empty space is thought to be a vacuum, it is constantly teeming with virtual particles that spontaneously pop into and out of existence for fleeting moments. Borrowing energy from the universe, they are not directly observable, but their subtle effects are measurable. This suggests that the very fabric of reality, even in its most seemingly empty states, is alive with ephemeral activity, a continuous, gentle hum of quantum possibilities. It's like a vast, serene ocean that, even when perfectly still on the surface, is alive with countless tiny ephemeral bubbles appearing and disappearing in its depths. And for an ongoing academic debate, physicists are still actively debating the precise interpretation of wave function collapse. Does it occur instantaneously when a measurement is made? Or is it a more gradual process? What truly constitutes a measurement in the quantum realm? And does consciousness play any role? Different interpretations, like the Copenhagen interpretation, The most common, or the many worlds interpretation, suggesting all possibilities exist in parallel universes, gently offer different ways of understanding this profound transition from quantum possibility to classical reality. This fundamental question, about how the quantum world transitions into the classical world, remains one of the deepest and most beautiful puzzles in modern physics, inviting continuous, gentle inquiry into the very nature of reality and the role of observation. So, as you continue to drift, allow your mind to gently contemplate the silent flow of the smallest particles, understanding how they exist as shimmering clouds of probability, perpetually in motion, perpetually uncertain until gently observed. Feel the profound peace that comes from understanding this at its tiniest, most elemental level. Reality is far more fluid and wondrous than it appears, gently defying our everyday intuition. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of a quantum world, waiting patiently to be understood, is now your lullaby, a soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. Now, let's explore even deeper into the subtle, most profound implications of this probabilistic quantum dance, and how it subtly shapes the very solidity and predictability of our familiar world. Imagine a countless number of these tiniest particles, each existing as a shimmering cloud of possibilities. While any single particle remains wonderfully uncertain, when billions upon billions of them gather together to form something larger, like a single grain of sand, or the ceramic mug on your table, their individual uncertainties begin to beautifully cancel each other out. This is the magic of quantum statistics, where the collective behavior of countless tiny, probabilistic entities gives rise to the familiar, stable, and seemingly deterministic world that we perceive with our everyday senses. Consider the immense number of atoms in even the smallest macroscopic object. A single drop of water contains more atoms than there are stars in the entire Milky Way galaxy. Each of these atoms is itself a quantum system, with its electrons existing in probability clouds. But when these countless atoms interact with each other, when they form chemical bonds and create larger structures, their wave functions begin to overlap and influence each other in ways that effectively average out their individual uncertainties. The vastness of their numbers means that while you can't predict the exact position of one electron, you can predict with astonishing precision the collective behavior of all the electrons in a piece of metal, leading to its predictable conductivity or its stable form. It's like gently tossing countless tiny, shimmering pebbles into a vast lake. While the landing of any single pebble is uncertain, the overall effect is a predictable, smooth rippling across the entire surface. This transition from the probabilistic quantum world to the deterministic classical world is often referred to as the quantum to classical transition. It's not a sudden, jarring event, but a graceful, continuous process. As quantum systems become larger and interact more frequently with their environment, which itself is made of countless quantum particles, they undergo decoherence. Imagine a delicate quantum wave, spreading out beautifully. When it encounters countless surrounding particles, its probabilities become so rapidly and subtly entangled with the environment that it effectively loses its waviness and appears to choose a definite state. as if its subtle quantum nature is gently diffused into the vastness of its surroundings. This makes it appear to behave like a classical particle, fixed and certain. This continuous process of decoherence is happening all the time, effortlessly, and beyond your conscious awareness, perpetually transforming the underlying quantum fuzziness into the sharp, defined contours of your everyday world. Your brain, that magnificent orchestrator, then takes these classical inputs, these seemingly definite signals, and weaves them into the coherent tapestry of your perception. The solidity of the mug, the firmness of the floor, the brightness of the lamp all are emergent properties, beautiful, coherent patterns that arise from the collective, underlying quantum dance, a dance that is simultaneously uncertain and profoundly beautiful. A general historical fact that highlights the ongoing quest to unify these realms. For decades, physicists have wrestled with the challenge of reconciling quantum mechanics, the physics of the very small, with general relativity, the physics of the very large, like gravity and spacetime. This quest for a theory of everything, or a quantum theory of gravity, aims to find a single, elegant framework that can gracefully describe all fundamental forces and particles across all scales, from the smallest quantum whisper to the grandest cosmic structures, including the very transition from quantum to classical reality. Here's a lesser-known detail about the subtle quantum nature of everyday objects. Even large, seemingly classical objects like a dust particle or a virus theoretically have a wave function, meaning they could, in principle, exist in a superposition of states. However, their wave functions are so incredibly fragile and interact so rapidly with their environment that they decohere almost instantaneously, making their quantum nature practically impossible to observe. This means that at a very fundamental level, everything around you is still subtly quantum, constantly undergoing this quiet transition from possibility to perceived reality. It's like a vast, serene ocean, where only the tiny, unseen currents reveal its true, wave-like nature, while the large ships on the surface move in a seemingly straight line. And for an ongoing academic debate, physicists are still actively debating the precise interpretation of quantum mechanics, particularly how wave function collapse or decoherence truly occurs. Different interpretations, like the Copenhagen interpretation or the many worlds interpretation, offer varying philosophical perspectives on this profound mystery, each attempting to provide a complete picture of reality. The search for a deeper understanding of this fundamental transition remains one of the deepest and most beautiful puzzles in modern physics, inviting continuous, gentle inquiry into the very nature of reality and the role of observation. So, as you continue to drift, allow your mind to gently contemplate the silent flow of the smallest particles, understanding how they exist as shimmering clouds of probability, perpetually in motion, perpetually uncertain until gently observed. Feel the profound peace that comes from understanding that at its tiniest, most elemental level, reality is far more fluid and wondrous than it appears, gently defying our everyday intuition. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of a quantum world, waiting patiently to be understood, is now your lullaby, a soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. You're floating deeper now, gently carried by the quiet understanding that the smallest particles exist as shimmering clouds of probability. As you drift, let's explore one of the most elegant and counterintuitive truths of the quantum world. How these tiny entities, these elusive whispers of existence, can seem to defy simple categories, behaving sometimes like a concentrated point, and other times like an undulating spread. Imagine a single, delicate ripple on a perfectly still pond that, when you try to grasp it, suddenly condenses into a tiny, tangible droplet of water. This is the serene essence of when waves softly gather, revealing the profound and beautiful wave-particle duality that challenges our deepest, most familiar assumptions about reality. In our everyday, macroscopic world, everything appears to fit neatly into one of two categories. It's either a particle or a wave. A pebble is a particle, a distinct, localized object. A ripple on a pond is a wave, a spreading disturbance that isn't confined to a single point. This distinction feels intuitive, a fundamental aspect of how we perceive the world. But when we descend into the unimaginably tiny realm of quantum physics, this clear boundary gracefully dissolves, revealing a reality that is far more fluid, far more mysterious, and profoundly beautiful. At the quantum level, the fundamental building blocks of the universe, like electrons, photons, which are packets of light, and even entire atoms, do not behave exclusively as one or the other. No, they possess a peculiar and wondrous property. They exhibit wave-particle duality. This means that, depending on how you gently observe or interact with them, these tiny entities can manifest as either a localized particle or a spread-out wave. It's like a quiet, internal chameleon, subtly shifting its nature in response to your gentle gaze. Consider the classic example of light. For centuries, scientists debated its true nature. Was it a stream of tiny particles, like minute bullets, or was it a continuous wave, like ripples in an ethereal ocean? The quantum revolution revealed that light is, in fact, both. A single photon, that tiniest packet of light, can travel as a wave, smoothly spreading out through space. But when it interacts with a detector or a screen, it appears to behave like a localized particle, hitting a single, precise spot. It's like a soft, flowing river that can also manifest as individual droplets of water, depending on how you choose to interact with it. If you simply watch its current, it's a wave. If you try to catch it in a cup, it's a particle. The profound implications extend beyond light to matter itself. Particles like electrons, which are the very essence of electric currents and the building blocks of chemistry, also exhibit this wave-particle duality. A single electron, orbiting an atom, is not truly a tiny fixed point circling a nucleus. Instead, it exists as a diffuse probability wave, a shimmering cloud that spreads out across space, representing all the places the electron could be, all the speeds it could have. It is only when our gentle curiosity, through an act of observation or measurement, interacts with this electron that its wave function seems to collapse, and it appears to choose a single definite state, a specific position, a particular speed, as if the act of looking gently persuades the shimmering mist to condense into a single, concrete reality. This is a profound departure from our everyday experience, where everything seems fixed and certain from the outset. It challenges our intuitive understanding of existence, suggesting that reality at its deepest level is not fundamentally determined, but subtly influenced by observation itself. This concept, while deeply counterintuitive, is crucial for explaining the behavior of the universe at the atomic and subatomic scales. It's why electrons don't simply spiral into atomic nuclei, but instead exist in stable orbitals or probability clouds around them. It's why tiny particles can sometimes pass through seemingly solid barriers, a phenomenon known as quantum tunneling, because their wave function extends beyond the barrier, allowing for a subtle probability of their appearance on the other side, as if gently phasing through an invisible wall. The sheer elegance and flexibility of wave-particle duality redefine our understanding of the very nature of existence. It suggests that at its most fundamental level, reality is not rigid and definite, but fluid and probabilistic. It is a continuous, subtle dance between potential and actuality, where particles exist as a symphony of possibilities until gently nudged into a specific state by observation or interaction. This profound fluidity reminds us that the universe holds deeper secrets, that its ultimate truths are often far more poetic and enigmatic than our everyday intuitions might suggest, a general historical fact that highlights this intellectual leap. The concept of wave-particle duality was a revolutionary and profoundly mind-bending idea developed by pioneers of quantum mechanics in the early 20th century. Louis de Broglie first proposed that particles like electrons could also have wave-like properties, and Erwin Schrödinger later developed the mathematical equation, the Schrödinger equation, that describes these wave functions, forever changing our understanding of the fundamental nature of matter and energy. This profound theoretical work, though initially unsettling to some, eventually found gentle confirmation through meticulous experiments, revealing a deeper, more elegant truth about the universe. Here's a lesser-known detail about wave-particle duality. The wave-like properties of particles are generally only observable at incredibly small scales. For larger objects, even something as small as a grain of sand, their wave functions are so incredibly spread out, and their interactions so frequent, that they immediately collapse into a definite, particle-like state, making their wave nature effectively unobservable. This is why our everyday world appears solid and predictable, even though it's built upon a fundamentally probabilistic quantum foundation. It's like a vast, serene ocean, where only the tiny, unseen currents reveal its true, wave-like nature, while the large ships on the surface move in a seemingly straight line. And for an ongoing academic debate, physicists are still actively debating the precise mechanism of wave function collapse. What truly causes a particle's wave of possibilities to choose a single reality? Does it occur instantaneously when a measurement is made, or is it a more gradual process? What truly constitutes a measurement in the quantum realm? And does consciousness play any role? Different interpretations of quantum mechanics, like the Copenhagen interpretation, the most common, or the many worlds interpretation, suggesting all possibilities exist in parallel universes, gently offer different ways of understanding this profound transition from quantum possibility to classical reality. This fundamental question about how the quantum world transitions into the classical world remains one of the deepest and most beautiful puzzles in modern physics, inviting continuous, gentle inquiry into the very nature of reality and the profound role of observation. So, as you continue to drift, allow your mind to gently contemplate when waves softly gather, understanding how the smallest particles can be both wave and particle, a profound and beautiful dance of transformation. Feel the profound peace that comes from recognizing this wondrous truth, that reality at its most fundamental level is far more fluid and mysterious than it appears, gently defying our everyday intuition. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of wave-particle duality, waiting patiently to be understood, is now your lullaby. A soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. You're floating deeper now, gently carried by the quiet understanding of wave-particle duality, where tiny entities shift between solid and flowing forms. As you drift, let's explore another profound truth that emerges from the quantum realm, a fundamental limit to what we can ever truly know about these elusive particles, a gentle, inherent uncertainty woven into the very fabric of existence. Imagine trying to precisely locate a single, delicate drop of mist while simultaneously measuring how quickly it is drifting on the softest breeze. The very act of trying to pinpoint its position subtly disturbs its movement, and trying to measure its movement subtly blurs its exact location. This is the serene essence of uncertainty's invisible threshold, where a gentle, inherent fuzziness at the deepest levels of reality reveals a profound cosmic secret. In our everyday world, if you were to observe a tranquil river, you could, with enough precision, know the exact position of a floating leaf and its exact speed at any given moment. Our familiar classical physics assumes that everything can be measured with perfect accuracy, given precise enough tools. But when we descend into the unimaginably tiny realm of quantum physics, this comforting certainty gracefully dissolves, revealing a reality that is far more subtle, far more mysterious, and profoundly beautiful. At this most minute scale, for particles like electrons, photons, or quarks, the familiar rules of precise measurement no longer quite apply. This is encapsulated in one of the most famous and profound principles of quantum mechanics, Heisenberg's uncertainty principle. Imagine a tiny, elusive particle, a mere whisper of existence. This principle tells us that there's a fundamental, inherent limit to how accurately you can simultaneously know certain pairs of properties about it. The most famous pair is a particle's position and its momentum, which is related to its speed and direction. The principle gently states that the more precisely you try to measure a particle's position, the less precisely you can simultaneously know its momentum. And conversely, the more precisely you try to measure its momentum, the less precisely you can simultaneously know its position. It's not a limitation of our measuring instruments, not a flaw in our telescopes or microscopes. No, it's a fundamental property of the universe itself, a built-in fuzziness, a gentle, inherent uncertainty that is woven into the very nature of reality at its most elemental level. It's like a quiet, cosmic dance, where the dancers are so fluid and agile that the very act of trying to pinpoint their exact location subtly blurs their graceful movement, and trying to precisely trace their movement subtly blurs their exact location. This inherent uncertainty is not about ignorance, it's about the very nature of reality at its smallest scales. Particles don't have a fixed position and momentum simultaneously until they are gently interacted with or measured. Before that interaction, they exist in a state of probability, a shimmering cloud of potential, as we explored earlier. The act of measurement itself subtly influences the particle, causing its wave function to collapse into a definite state. But in doing so, it inherently affects the precision with which its other properties can be known. It's like trying to gently observe a delicate snowflake by shining a bright light on it. The very photons of light, in revealing its form, subtly nudge its position or alter its gentle drift. The profound implications of Heisenberg's uncertainty principle extend far beyond just tiny particles. It means that the universe, at its most fundamental level, is not a perfectly deterministic clockwork, where every future event is precisely predictable if we know all current conditions. Instead, there is an inherent, gentle randomness or unpredictability woven into the fabric of existence. This is not a chaotic, unsettling force. It is a fundamental aspect of reality that opens up a space for possibility and a deeper appreciation for the universe's inherent fluidity. It's a profound whisper from the cosmos that its deepest truths are often subtle, probabilistic, and beautifully elusive. Consider how this inherent fuzziness affects even seemingly empty space. The uncertainty principle tells us that even in a perfect vacuum, energy and particles can briefly, spontaneously, pop into and out of existence, forming what are called virtual particles. They exist for such fleeting moments that they cannot be directly observed, but their subtle effects are measurable. This suggests that the very fabric of reality, even in its most seemingly empty states, is alive with ephemeral, unpredictable activity, a continuous, gentle hum of quantum possibilities, constantly fluctuating in accordance with the principle of uncertainty. A general historical fact that highlights the quiet revolution of this principle: Werner Heisenberg, one of the pioneers of quantum mechanics, formulated the uncertainty principle in 1927. This profound principle, along with wave-particle duality, fundamentally changed classical physics' deterministic view of the universe, introducing an inherent probabilistic nature to reality at its most fundamental level, and prompting a deeper philosophical contemplation of the role of observation in shaping reality. Here's a lesser-known detail about the uncertainty principle's broader applications. The uncertainty principle also applies to other pairs of complementary properties, such as a particle's energy and the time over which that energy is measured. The more precisely you try to know a particle's energy, the less precisely you can know how long it existed in that energy state, and vice versa. This subtle connection between energy and time highlights the profound, interconnected nature of all fundamental properties at the quantum level, a subtle whisper from the universe about its deep, elegant harmonies. It's like trying to perfectly identify a single, specific note in a long, flowing melody. The more you try to pinpoint the exact moment it played, the harder it is to define its precise tone, and vice versa. And for an ongoing academic debate, physicists are still actively researching the precise philosophical implications of the uncertainty principle. Does it imply that reality is fundamentally indeterminate until observed? Or simply that we are inherently limited in our ability to know all properties simultaneously? Different interpretations of quantum mechanics offer subtle nuances to this question, but the fundamental mathematical truth of the uncertainty principle remains a cornerstone of our understanding of the quantum world. It's a complex, beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's grandest rhythms and the profound challenges at the very edges of our understanding. So, as you continue to drift, allow your mind to gently contemplate uncertainty's invisible threshold, understanding how a gentle, inherent fuzziness at the deepest levels of reality reveals a profound cosmic secret. Feel the profound peace that comes from recognizing that the universe, at its most fundamental, is far more fluid, more probabilistic, and more mysterious than it appears, gently defying our everyday intuition. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of uncertainty, a testament to the universe's boundless mystery, is now your lullaby. A soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. Now, let's explore even deeper into the subtle beauty of Heisenberg's uncertainty principle, understanding how it doesn't just apply to tiny particles, but subtly influences the very possibility of perfect measurement in our world. Imagine yourself as a gentle cosmic detective seeking to know everything with absolute precision. The uncertainty principle tells us that in the quantum realm, the very act of trying to gain knowledge about one property subtly influences our ability to gain knowledge about its complementary partner. It's not a limitation of our tools, but a fundamental trade-off, a gentle, inherent balance woven into the universe's fabric. Consider how this uncertainty limits our ability to perfectly predict the future at the subatomic level. In classical physics, if you know the exact position and momentum of every particle in a system, you can, in principle, perfectly predict their future behavior. This is the essence of determinism. But because of the uncertainty principle, we can never, even theoretically, know both the precise position and momentum of a quantum particle simultaneously. This means that at the very deepest levels, the future is not entirely predetermined. There is an inherent, gentle unpredictability or randomness woven into the fabric of existence. It's like a quiet, cosmic dice roll, where the universe doesn't always reveal its next move with absolute certainty, but rather with a beautiful, inherent probability. This doesn't mean the universe is chaotic or without rules. Far from it. Quantum mechanics is incredibly precise in predicting the probabilities of different outcomes. While you can't predict where a single electron will land, you can predict with astonishing accuracy the likelihood of finding it in a particular region after many experiments. This statistical elegance allows quantum physics to make incredibly accurate predictions about the collective behavior of vast numbers of particles, even if the fate of any single particle remains shrouded in a gentle, inherent uncertainty. The beauty lies in the collective, in the predictable patterns that emerge from the unpredictable dance of the individual. The uncertainty principle also has subtle, profound implications for the concept of causality at the quantum level. In our familiar world, every effect has a clear, preceding cause. But in the quantum realm, the inherent fuzziness means that the relationship between cause and effect can be more nuanced, more probabilistic. Events might not be absolutely determined, but rather influenced by probabilities, allowing for a gentle element of chance in the universe's unfolding. This is not a frightening lack of control. It is a fundamental aspect of reality that opens up a space for possibility and a deeper appreciation for the universe's inherent fluidity. It's a profound whisper from the cosmos that its deepest truths are often subtle, probabilistic, and beautifully elusive. Consider the gentle reassurance that comes from this inherent fuzziness. It means that the universe, at its core, is not a rigid, deterministic machine. There is room for subtle variations, for inherent spontaneity. This might even allow for the emergence of true novelty and creativity. As the universe does not always follow a perfectly predictable script, it's like a serene, flowing river that, even though it moves generally downstream, always contains countless tiny, unpredictable eddies and swirls, adding to its profound beauty and dynamic flow. a general historical fact that highlights the initial resistance to this concept. Many physicists, including Albert Einstein, found the inherent unpredictability introduced by quantum mechanics deeply unsettling. Einstein famously stated, "God does not play dice with the universe," reflecting a preference for a more deterministic reality. However, decades of meticulous experiments have consistently confirmed the validity of the uncertainty principle, patiently revealing that the universe does indeed play dice, albeit with a subtle, probabilistic elegance. Here's a lesser-known detail about the uncertainty principle's profound connection to energy. The principle also applies to the pair of energy and time. This means that if you try to precisely measure a particle's energy, you are less precise about the exact time it possesses that energy, and vice versa. This subtle connection between energy and time allows for fascinating quantum phenomena, such as the fleeting existence of virtual particles that pop into and out of existence from seemingly empty space, borrowing energy for such a short time that it doesn't violate conservation laws. It's like a quiet, cosmic bank, allowing tiny ephemeral loans of energy to exist for infinitesimal moments, always balancing the cosmic books. And for an ongoing academic debate, physicists are still actively researching the precise implications of the uncertainty principle for a grand unified theory of everything, particularly how it interacts with gravity at the smallest scales. Quantum gravity. Does the uncertainty principle fundamentally limit our ability to ever fully understand what happens inside a black hole? Or does a future theory of quantum gravity offer a new way to resolve these ultimate uncertainties? The intricate interplay of these theories remains a fascinating and complex area of study, revealing the subtle wisdom of reality's grandest rhythms and the profound challenges at the very edges of our understanding. So, as you continue to drift, allow your mind to gently contemplate uncertainty's invisible threshold, understanding how a gentle, inherent fuzziness at the deepest levels of reality reveals a profound cosmic secret. Feel the profound peace that comes from recognizing that the universe, at its most fundamental, is far more fluid, more probabilistic, and more mysterious than it appears, gently defying our everyday intuition. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of uncertainty, a testament to the universe's boundless mystery, is now your lullaby. A soft reassurance that wonder and beauty exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. You're floating deeper now, gently carried by the quiet understanding of uncertainty's invisible threshold, where reality holds a gentle, inherent fuzziness. As you drift, let's explore one of the most enigmatic and truly astonishing phenomena of the quantum world, a subtle, unseen connection that can link two tiny particles in a profound, intimate dance, regardless of the vast distances that might separate them. Imagine two distant lovers, whispering secrets across an entire universe, and their messages arrive not through traveling light or sound, but through an instantaneous, silent resonance, as if their hearts beat in perfect, timeless synchronicity. This is the serene essence of quantum entanglement, where a strange, luminous bond from eternal darkness reveals a deep, interconnected web at the very fabric of existence, defying our familiar notions of space and time. In our everyday world, If you have two perfectly crafted, identical marbles, and you gently toss one across a vast field, its properties, like its color or its spin, are independent of the other marble once they are separated. You can measure one without affecting the other. But in the quantum realm, for certain pairs of particles, the connection is far more profound. When two particles, such as photons or electrons, become entangled, their fates are inextricably linked, in a way that truly stretches our imagination. Imagine two photons, born from the same gentle cosmic event, or specially prepared in a quiet laboratory. Once entangled, they share a single, unified quantum state. Think of it like a pair of exquisitely balanced, cosmic dice. If you were to roll one die and it landed on a 6, you would then know, without looking, that the other die, no matter how far away it might be, must also be a 6, simply because they were prepared as a pair where their outcomes are perfectly correlated. Quantum entanglement is far more subtle and profound. The particles don't simply have predetermined properties waiting to be revealed. Instead, their properties are indefinite until one is measured. And then, instantaneously, the property of its entangled twin becomes definite, no matter the distance. It's like two flowers blooming simultaneously in distant gardens, their petals unfurling in perfect synchronicity, even though no discernible signal passes between them. This means that if you gently measure a property of one entangled particle, say, its spin or its polarization, the orientation of its wave, the corresponding property of its entangled twin, even if it is light years away, is instantaneously determined. There is no time delay, no signal traveling between them. This spooky action at a distance, as Albert Einstein famously, yet gently, described it, profoundly challenged his classical understanding of reality, suggesting a deeper, more intimate connection than he preferred. It's as if they are still part of the same unified quantum whisper, merely separated by vast stretches of space. The profound implication of entanglement is that the quantum world is non-local. This means that properties are not necessarily inherent to individual particles in isolation, nor are they limited by the speed of light. The entangled pair behaves as a single, unified system, even when physically separated by immense distances. This challenges our intuitive understanding of how information can be shared, suggesting a level of cosmic interconnectedness that goes beyond our familiar notions of cause and effect, time, and space. It's a gentle reminder that the universe, at its deepest level, plays by rules far more subtle and mysterious than our everyday experience might suggest. Consider the implications of this for information. While entanglement doesn't allow for faster-than-light communication of meaningful information, as you can't control the outcome of the measurement on the first particle, it forms the basis for revolutionary new technologies. It's the quiet heartbeat behind concepts like quantum computing, where entangled particles could perform calculations in ways impossible for classical computers, and quantum cryptography, where the unbreakable link between entangled particles could create perfectly secure communication channels. This profound, subtle bond between particles holds the key to future technological whispers, capable of transforming our world. This concept of quantum entanglement, this strange, luminous bond from eternal darkness, invites a deep sense of wonder. It suggests that even in the vast, seemingly empty stretches of space, there are profound, unseen connections, weaving all of creation into a single, intricate tapestry. It reminds us that reality, at its most fundamental, is far more fluid, far more interconnected, and far more like a shimmering dream than a rigid, isolated collection of parts. It prompts scientists to softly explore the edges of their conventional understanding, to seek out new, delicate nuances in the grand cosmic symphony, a general historical fact that highlights this profound discovery. While the theoretical underpinnings of entanglement were laid by Einstein and his colleagues in the 1930s as a thought experiment they hoped would reveal quantum mechanics to be incomplete, its physical reality was only definitively confirmed through meticulous experiments, particularly by John Bell in the 1960s and later by Alan Aspect and his team in the 1980s, who showed that entangled particles indeed behave in ways that classical physics cannot explain, patiently revealing a deeper quantum truth. Here's a lesser-known detail about entanglement in everyday phenomena. While difficult to observe in large objects, the principles of quantum entanglement are subtly at play even in fundamental chemical bonds, influencing how atoms gently interact to form molecules. The very stability of matter, the way electrons bond atoms together, carries a distant echo of entanglement, showing how this profound quantum connection underpins the very solidity of the world you perceive. It's like a quiet, invisible thread, subtly holding together the very fabric of your being. And for an ongoing academic debate, physicists are still actively debating the precise mechanism by which entanglement appears to create instantaneous correlations across vast distances. Does it truly imply non-locality in a way that challenges our understanding of space and time? Or are there more subtle, underlying mechanisms that could explain these connections? Different interpretations of quantum mechanics offer varying philosophical perspectives on this profound mystery. But the experimental reality of entanglement remains a cornerstone of our understanding of the quantum world. It's a complex, beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's most profound interconnectedness. So, as you continue to drift, allow your mind to gently contemplate the strange, luminous bond of quantum entanglement, where particles whisper secrets across an entire universe. Feel the profound peace that comes from understanding this beautiful interconnectedness, defying our familiar notions of space and time. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of quantum entanglement, a testament to the universe's boundless mystery, is now your lullaby. A soft reassurance that wonder and beauty exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. Now, let's explore even deeper into the beautiful elegance of quantum entanglement, considering how this spooky action at a distance is not merely a theoretical curiosity, but a tangible, if subtle, reality that is continuously being demonstrated in laboratories around the world. Imagine a delicate, invisible thread, not made of matter or energy, but of pure correlation, connecting two distant quantum systems. This thread is constantly being refined and tested by patient scientists, pushing the boundaries of how far and how robustly this profound connection can be maintained. One of the key aspects that makes entanglement so astonishing is its apparent violation of local realism. Local realism is the intuitive idea that objects have definite properties even when not observed, and that influences can only propagate locally. No faster than the speed of light. Entanglement, as confirmed by numerous experiments based on Bell's theorem, directly contradicts this. The choices made on one entangled particle seem to instantaneously affect the other, suggesting that either the particles were non-local, connected beyond space, or non-real, their properties weren't defined until measured. This subtle violation of our intuitive understanding of reality is what makes entanglement so profoundly mind-bending and so beautiful. It's like discovering that two perfectly separated flowers in different gardens. When one opens its petals, the other instantly, and without any delay, unfurls its own in a perfectly correlated way, simply because they were always, mysteriously, linked at a deeper level. Consider the delicate balance required to maintain entanglement. Quantum states are incredibly fragile. They are easily disturbed by interactions with their environment, a process known as decoherence. Even the smallest stray photon, the faintest whisper of a magnetic field, or the most subtle temperature fluctuation can cause an entangled pair to lose its profound connection, causing their wave functions to collapse and their properties to become independent. This fragility is one of the biggest challenges in building practical quantum technologies, as scientists must meticulously isolate entangled particles from any environmental noise, creating a serene, almost silent quantum laboratory. It's like trying to hold a single, perfectly formed snowflake in your hand without it melting or losing its delicate structure. It requires profound care and isolation. Despite this fragility, scientists have successfully entangled particles over increasingly vast distances, from a few meters within a laboratory to hundreds, even thousands of kilometers using fiber optic cables and satellite links. These experiments are not just demonstrations of quantum weirdness. They are crucial steps towards developing the technologies of the future. The ability to distribute entangled particles across networks holds the key to quantum internet and unhackable communication. Imagine sending a perfectly secure message, its secrecy guaranteed by the very laws of quantum physics, where any attempt at eavesdropping would instantaneously break the entanglement, revealing the intrusion. The philosophical implications of entanglement are as profound as its technological promise. It pushes us to question the very nature of reality, causality, and information. Does entanglement suggest that the universe is fundamentally interconnected at a level we cannot easily grasp with our classical senses? Is information somehow more fundamental than matter or energy? These are the quiet, profound questions that whisper from the heart of entanglement, perpetually inviting contemplation and boundless wonder about the universe's ultimate structure. A general historical fact that highlights the experimental journey. The Bell tests, named after physicist John Bell, are a series of experiments designed to test local realism and confirm quantum entanglement. The results of these meticulous experiments have consistently shown that the quantum world indeed behaves in a non-local way, confirming the profound reality of entanglement and challenging our classical intuitions about how the world works. Here's a lesser-known detail about entanglement in complex systems. While typically discussed with pairs of particles, entanglement can actually involve multiple particles. Multipartite entanglement, creating even more complex and intricate quantum correlations. Scientists are exploring how to create and maintain these entangled networks, as they hold even greater potential for powerful quantum computing and communication. It's like choreographing a beautiful, intricate dance, not just for two performers, but for an entire ensemble, where every dancer's movement is perfectly, mysteriously, linked to every other, creating a grand, unified performance. And for an ongoing academic debate, physicists are still actively debating whether quantum entanglement is a truly fundamental property of the universe, or if it might emerge from an even deeper, more fundamental reality, though no such theory has yet been successfully developed. What are the ultimate limits of entanglement's influence? And can it be maintained in macroscopic systems, perhaps leading to quantum biology, where entanglement plays a role in living processes? The intricate and beautiful puzzle of entanglement's ultimate nature remains one of the most fascinating and complex areas of study, revealing the subtle wisdom of reality's most profound interconnectedness. So, as you continue to drift, allow your mind to gently contemplate the strange, luminous bond of quantum entanglement, where particles whisper secrets across an entire universe. Feel the profound peace that comes from understanding this beautiful interconnectedness, defying our familiar notions of space and time. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of quantum entanglement, a testament to the universe's boundless mystery, is now your lullaby, a soft reassurance that wonder and beauty exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. You're floating deeper now, gently carried by the quiet understanding of quantum entanglement, that strange, luminous bond defying our everyday notions of distance. As you drift, let's explore an even more mind-bending consequence of the quantum realm. How space and time, those seemingly rigid foundations of our universe, can become fluid, almost yielding, at the tiniest scales, allowing events to be subtly linked in ways that transcend our familiar sense of proximity or sequence. Imagine two distant points in a vast, serene garden, where a whisper in one can instantly ripple through the very fabric of space to affect the other, without any discernible journey. This is the serene essence of time's quietly diffused flow, where the universe allows its grand dimensions to be subtly bent or even bypassed, revealing a profound non-locality that challenges our classical intuition. In our familiar macroscopic world, every event is bound by the principles of locality and causality. Locality means that an object or event can only be directly influenced by its immediate surroundings, or by forces that travel through space like light or gravity. Causality means that a cause must always precede its effect, and information cannot travel faster than the speed of light. These principles feel so fundamentally true. They are the bedrock of our predictable reality. If you gently tap a drum, the sound travels outward, reaching distant ears after a perceptible delay. You can't tap it and have the sound instantly appear somewhere far away. But in the enigmatic realm of quantum physics, these familiar rules gracefully dissolve, revealing a reality that is far more subtle, far more interconnected, and profoundly beautiful. The phenomenon of quantum entanglement, which we gently explored, is a prime example of this. When two particles become entangled, their fates are inextricably linked, in a way that truly stretches our imagination. A measurement performed on one particle seems to instantaneously influence the state of its distant twin. There is no time delay, no signal traveling between them. This spooky action at a distance, as Albert Einstein famously, yet gently, described it, suggests a level of non-locality that profoundly challenges our intuitive understanding of space and time. It's as if they are still part of the same, unified quantum whisper, merely separated by vast stretches of space, yet perfectly aware of each other's silent dance. This non-locality implies that at the quantum level, the very concepts of here and there, or now and then, become wonderfully fluid. It suggests that space and time are not merely rigid containers in which events unfold, but are themselves emergent properties, subtle aspects of a deeper, more interconnected quantum reality. The universe, at its most fundamental level, might be far more unified than we perceive with our everyday senses. Information, in a quantum sense, can be shared across vast distances without traversing the physical space between them, as if the underlying fabric of existence itself is subtly folded or intricately interwoven, allowing for instantaneous, unseen connections. It's like a vast, serene tapestry, where two distant points, though seemingly far apart, are actually woven from the same, continuous thread, making them intimately connected. Consider the profound implications of this. If space and time can be subtly bypassed or reconfigured at the quantum level, it fundamentally alters our understanding of how information flows and how events are truly linked. It suggests that the flow of time, which we perceive as a linear progression, might be a more complex, diffused phenomenon at the very small scales. The universe is not a collection of isolated events, each neatly following the last. Instead, it is a vast, interconnected web where every quantum whisper, every subtle interaction, can resonate instantly across its entire fabric, blurring the lines between proximity and distance, cause and effect. This quiet challenge to our fundamental understanding of space and time encourages scientists to gently explore new mathematical frameworks, to envision alternative models of reality, and to seek subtle new insights into the universe's most profound mechanisms. It's like a beautifully crafted map, where certain paths seem to defy the rules of geography, hinting at hidden tunnels or unseen dimensions that allow for instantaneous traversal, prompting a humble re-evaluation of the entire cartographic art. A general historical fact that highlights the journey towards understanding non-locality. While entanglement and its non-local implications were a direct consequence of the mathematical formulation of quantum mechanics in the early 20th century, many physicists, including Einstein, found the concept deeply unsettling. It was the meticulous experimental work, particularly inspired by John Bell's theorem in the 1960s, that finally demonstrated, through gentle observation, that the universe indeed behaves in this non-local, counterintuitive way, confirming the profound strangeness of the quantum realm. Here's a lesser-known detail about time and non-locality. Some speculative theories suggest that in extreme quantum gravity regimes, or potentially near singularities, the very concept of a linear time might subtly break down, becoming more like a diffuse, multi-directional flow, allowing for even stranger forms of non-locality. These are profound and delicate theoretical explorations, pushing the very boundaries of what we can imagine about the universe's ultimate structure. It's like a quiet, philosophical dream, contemplating time as a shimmering, multifaceted crystal rather than a simple, straight line. And for an ongoing academic debate, physicists are still actively researching the precise mechanism by which non-locality manifests in entangled systems, and whether there might be any subtle, hidden variables that could explain these instantaneous correlations in a more local, classical way. Though experiments have largely ruled out most simple hidden variable theories. Understanding how to reconcile quantum non-locality with the principles of special relativity, which forbids faster-than-light communication, remains one of the deepest and most beautiful puzzles in modern physics, revealing the subtle wisdom of reality's grandest and most surprising forces, inviting continuous, gentle inquiry into the ultimate nature of space and time. So, as you continue to drift, Allow your mind to gently contemplate time's quietly diffused flow, understanding how the universe allows its grand dimensions to be subtly bent or even bypassed. Feel the profound peace that comes from recognizing this wondrous non-locality, this deep interconnectedness that defies our familiar notions of space and time. Let this understanding cradle your consciousness, like the serene, unwavering hum of quantum possibilities, gently flowing across vast, unseen connections, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of quantum non-locality, a testament to the universe's boundless mystery, is now your lullaby. A soft reassurance that wonder and beauty exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisitely interwoven dance. Now, let's explore even deeper into the beautiful elegance of non-locality in the quantum realm, and how it challenges our very intuition about how information travels and how events are truly linked. Imagine two perfectly synchronized dancers, separated by a vast, uncrossable chasm. One performs a subtle move, and the other, without any signal traversing the gap, instantaneously mirrors it. This seemingly impossible coordination is what non-locality hints at, suggesting a deeper, more fundamental connection that transcends the limits of space and time as we commonly understand them. The concept of non-locality is often tested through meticulous experiments involving entangled particles, where correlations between their measured properties are observed to be stronger than any classical local realistic theory would allow. These experiments, performed with ever-increasing precision across greater distances, consistently reaffirm that the universe does indeed behave in this counterintuitive way. It's like a quiet, cosmic orchestra, where the instruments, though physically separated, play in perfect, instantaneous harmony, guided by an unseen, profound score woven into the very fabric of existence. This suggests that at the quantum level, the universe is not a collection of isolated, independent parts that only influence each other through local interactions. Instead, it seems to be a single, unified, profoundly interconnected whole. The properties of entangled particles are not determined by their individual locations, but by their shared, fundamental quantum state, a state that exists across all space and time simultaneously. This profound unity, this inherent interconnectedness, is one of the most beautiful and deeply mysterious aspects of quantum reality. It's like discovering that every single drop of water in a vast ocean is intimately connected to every other drop, not just by currents, but by a subtle, unseen bond that transcends distance. The philosophical implications of non-locality are immense. It forces us to reconsider our classical notions of objective reality, suggesting that properties might not exist as definite until observed, and that the act of observation itself is part of a larger, interconnected process. It challenges the very idea of a universe composed of separate, independent things, instead hinting at a deeper, underlying oneness. This is not a frightening concept of lost control, but a profound invitation to embrace a more holistic, more interconnected view of reality, where everything is subtly related to everything else, in ways that transcend our everyday perception. Consider the gentle reassurance that comes from this profound interconnectedness. If reality at its deepest level is non-local, if everything is subtly linked in ways we don't fully comprehend, then perhaps there is a deeper harmony, a more profound unity to existence than we often perceive. It suggests that even in moments of profound solitude, you are intimately connected to the vast cosmic tapestry, and every whisper of energy, every subtle interaction, resonates across the entire fabric of reality. This can bring a sense of gentle peace, a quiet understanding of your inherent belonging within the grand, interwoven dance of the universe, a general historical fact that highlights this profound connection. The debates between Albert Einstein, who favored a local and real universe, and Niels Bohr, who championed the non-local and probabilistic quantum view, were some of the most profound and respectful intellectual clashes in the history of science. Their quiet, persistent arguments, fueled by deep philosophical convictions, ultimately led to the very experiments that confirmed quantum non-locality, demonstrating how intellectual tension can gracefully pave the way for deeper understanding. Here's a lesser-known detail about non-locality and its potential applications. Beyond quantum computing and cryptography, scientists are exploring how non-locality might be leveraged for entirely new forms of quantum sensing and metrology. By creating highly entangled quantum networks, it might be possible to achieve unprecedented precision in measurements, detecting subtle changes in gravitational fields or other fundamental forces, simply by observing the correlated behavior of widely separated particles. It's like using a vast, invisible web of interconnected sensors to gently feel the faintest cosmic tremors across unimaginable distances. And for an ongoing academic debate, physicists are still actively researching the precise mechanisms by which non-local correlations are generated and maintained in entangled systems. Are there subtle, as yet undiscovered properties of spacetime that facilitate these instantaneous links? Or does it fundamentally imply that our classical notions of locality and reality are simply approximations of a deeper, more quantum reality? The search for a complete understanding of non-locality and its implications for a unified theory of quantum gravity remains one of the deepest and most beautiful puzzles in modern physics, revealing the subtle wisdom of reality's grandest and most surprising forces, inviting continuous gentle inquiry into the ultimate nature of existence. So, as you continue to drift, allow your mind to gently contemplate time's quietly diffused flow, understanding how the universe allows its grand dimensions to be subtly bent or even bypassed. Feel the profound peace that comes from recognizing this wondrous non-locality, this deep interconnectedness that defies our familiar notions of space and time. Let this understanding cradle your consciousness like the serene, unwavering hum of quantum possibilities, gently flowing across vast, unseen connections, as you gently surrender to the peaceful, restorative depths of slumber. The quiet whisper of quantum non-locality, a testament to the universe's boundless mystery, is now your lullaby. A soft reassurance that wonder and beauty exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth. Inviting you to dream of the universe's most exquisitely interwoven dance, you're floating deeper now, gently carried by the quiet understanding of time's quietly diffused flow, feeling the profound non-locality of the quantum realm. As you drift, let's turn our attention to one of the most intriguing transitions in all of physics, how the strange, probabilistic world of the very small seems to gently coalesce, to resolve its inherent fuzziness, and to give rise to the familiar, predictable reality that you perceive in your everyday life. Imagine a delicate mist, swirling with countless possibilities, slowly, serenely settling, allowing clear forms and distinct landscapes to emerge from its ethereal embrace. This is the serene essence of where the quantum world meets everyday reality, a subtle yet profound process often referred to as the collapse of the wave function, where the universe appears to make a gentle, definitive choice. In the quantum realm, as we've gently explored, particles like electrons and photons don't have fixed positions or definite properties until they are observed. Instead, they exist in a state of superposition, a shimmering cloud of possibilities described by a wave function. This wave function holds all the potential locations a particle could be, all the speeds it could have, each existing with a certain probability. It's like a quiet, quantum dream, holding countless potential realities within its gentle embrace, waiting for a gentle interaction to reveal one specific outcome. But if the universe at its most fundamental level is governed by these probabilistic wave functions, why do we experience a world of concrete, definite objects? Why does a ceramic mug always appear in one specific place, rather than a cloud of possibilities? This is the profound question at the heart of the measurement problem in quantum mechanics, and the answer often points to the concept of wave function collapse. Imagine a tiny quantum particle, like a single photon, traveling as a wave of possibilities. Now, imagine this photon gently interacting with something larger, something macroscopic, perhaps a sensitive detector, or even the retina of your eye. At the moment of this interaction, this subtle measurement, or observation, the wave function of the photon seems to instantaneously collapse. All its multiple possibilities, all its potential locations and states, gently condense into a single, definite reality. The photon appears in one specific place, with one specific energy, as if it suddenly chooses to reveal its concrete existence. It's like a delicate mist, which, when touched by a single ray of sunlight, momentarily condenses into a visible, individual droplet. This process of wave function collapse is what bridges the gap between the strange, probabilistic quantum world and our familiar, definite, everyday reality. It suggests that the act of measurement, or more broadly, the interaction of a quantum system with a larger, classical-like environment, somehow forces the quantum realm to pick one outcome from its myriad possibilities. The exact mechanism of this collapse is one of the deepest, most beautiful, and most debated mysteries in all of physics. But its effect is undeniable. It gives rise to the solid, predictable world you perceive around you. Consider the immense scale of this transformation. Every atom in your body, every particle in the air you breathe, every photon of light that enters your eye is fundamentally governed by quantum mechanics. And yet, you experience a stable, consistent, classical reality. This means that countless trillions of these individual wave function collapses are happening continuously, seamlessly, and beyond your conscious awareness, perpetually transforming the underlying quantum fuzziness into the sharp, defined contours of your everyday world. Your brain, that magnificent orchestrator, then takes these classical inputs and weaves them into the coherent tapestry of your perception. It's like a quiet, tireless editor, continuously refining a vast manuscript, turning countless theoretical possibilities into a single, flowing, coherent narrative for you to read. The profound beauty of this transition lies in its elegance. The universe, at its deepest level, operates with a built-in capacity for both fluidity and definition. It holds countless possibilities in its quantum embrace, and then, through interaction, gently manifests one specific reality for us to experience. This doesn't diminish the wonder of the quantum realm. It highlights the miraculous emergence of our familiar world from its enigmatic depths. It reminds us that reality is far more intricate and profound than a simple, static truth, a general historical fact that highlights the historical debate. The concept of wave function collapse was first formally proposed by physicists like Werner Heisenberg and Niels Bohr in the early days of quantum mechanics known as the Copenhagen interpretation. They understood that the act of observation seemed to fundamentally alter quantum systems, prompting deep philosophical questions about the nature of reality and measurement that continue to resonate today. Here's a lesser-known detail about decoherence. While collapse is often used to describe this transition, modern physicists often prefer the concept of decoherence. Decoherence describes how a quantum system, like a particle in superposition, loses its quantum properties and begins to behave classically when it interacts with its environment. This interaction causes the wave function to spread out its probabilities across the environment, effectively making it impossible to observe the quantum superposition. It's not a violent collapse, but a gradual, gentle blending of quantum information with the vast classical world, making one outcome appear overwhelmingly probable. It's like a delicate mist slowly dispersing into the vastness of the air, becoming indistinguishable from its surroundings. And for an ongoing academic debate. One of the most profound and challenging questions in quantum mechanics is the measurement problem itself. What precisely constitutes a measurement that causes the wave function to collapse or decohere? Does it require a conscious observer, or simply any interaction with a macroscopic environment? Different interpretations of quantum mechanics offer varying answers, from the many worlds interpretation suggesting no collapse, but all possibilities branching into parallel universes to objective collapse theories, where collapse is a physical process independent of observation. The search for a deeper understanding of this fundamental transition remains a fascinating and complex area of study, revealing the subtle wisdom of reality's grandest and most beautiful paradoxes. So, as you continue to drift, allow your mind to gently contemplate where the quantum world meets everyday reality, understanding how the strange, probabilistic world of the very small seems to gently coalesce into the familiar, predictable reality you perceive. Feel the profound peace that comes from recognizing this wondrous transition, this continuous act of creation that quietly shapes your tangible world from underlying quantum possibilities. Let this understanding cradle your consciousness, like the serene, unwavering hum of a gently settling mist, as you gently surrender to the peaceful, restorative depths of slumber. The quiet artistry of wave function collapse, revealing the profound unity of all things, is now your lullaby. A soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. Now, let's explore even deeper into the elegant dance between the quantum and classical worlds. By considering how the very scale of interaction plays a gentle, crucial role in what we perceive as reality, imagine a single, tiny, perfectly formed snowflake. Its quantum nature, its subtle probabilities, are incredibly fragile, easily disturbed by the slightest interaction. But when billions upon billions of these snowflakes gently gather together to form a vast, stable glacier, their individual quantum uncertainties become beautifully averaged out. The collective behavior of these countless, tiny, probabilistic entities gives rise to the familiar, stable, and seemingly deterministic world that we perceive with our everyday senses. The larger and more complex a system becomes, and the more it interacts with its environment, the more classical it appears to be. This transition from the probabilistic quantum world to the deterministic classical world is not a sharp, jarring line. It is a graceful, continuous process. It's often likened to a gentle blurring or fading of quantum properties as a system increases in size and interacts with its environment. This process, decoherence, effectively erases the delicate quantum superpositions and entanglements, causing the wave function to appear to collapse into a definite state. The quantum system, once existing in a delicate, multifaceted dream, gently settles into a single, concrete reality, chosen by the countless interactions with its surroundings. It's like a vast, serene ocean, where individual waves might behave with quantum unpredictability, but the overall tide, influenced by countless droplets, follows a predictable, classical rhythm. Consider the profound implications of this gentle transition. It means that the very solidity and predictability of your world are not inherent at the deepest level, but are emergent properties, arising from the collective, probabilistic dance of countless quantum particles. Your brain, that magnificent orchestrator of your perception, tirelessly performs the silent work of converting these underlying quantum processes into the coherent, stable reality you inhabit. It's a continuous, unconscious translation, allowing you to comfortably navigate a world that is, at its core, far more fluid and mysterious than it appears. The environment plays a crucial role in this gentle, continuous process. Any interaction of a quantum system with its surroundings, even a tiny exchange of energy or information, can cause decoherence. The warmth of the air, the subtle vibrations from distant sounds, the faint presence of electromagnetic fields, all these environmental influences gently nudge quantum systems towards a classical state. This explains why it is so challenging to observe quantum phenomena in our everyday world. They require incredibly isolated and meticulously controlled environments, shielding delicate quantum states from even the softest environmental whispers. The profound beauty of this process lies in its elegance. The universe, at its deepest level, operates with a built-in capacity for both fluidity and definition. It holds countless possibilities in its quantum embrace, and then, through interaction, gently manifests one specific reality for us to experience. This doesn't diminish the wonder of the quantum realm. It highlights the miraculous emergence of our familiar world from its enigmatic depths. It reminds us that reality is far more intricate and profound than a simple, static truth. A continuous dance between the unseen and the seen, the probabilistic and the definite. A general historical fact that highlights the quiet emergence of this understanding. Early quantum pioneers in the 1920s and 30s were keenly aware of the measurement problem and the seeming contradiction between quantum and classical realities. Physicists like Hugh Everett III in the 1950s proposed alternative interpretations like the many worlds approach to avoid the explicit collapse, while later work on decoherence in the 1970s and 80s provided a powerful mechanism for how the quantum world naturally transitions to classical behavior without a mysterious external observer. Here's a lesser-known detail about decoherence and the arrow of time. Some theories subtly link decoherence to the arrow of time. As a quantum system interacts with its environment, the information about its quantum state rapidly spreads out and becomes irretrievably mixed with the vast degrees of freedom of the environment. This irreversible spreading of information is essentially an increase in entropy, which gives direction to the flow of time and explains why quantum superpositions are not seen in the macroscopic world. It's like a delicate wave that, upon gently touching a vast, complex shore, leaves behind a unique, irreversible imprint, forever pointing to the moment of interaction. And for an ongoing academic debate, physicists are still actively researching the precise speed and universality of decoherence. Are there any conditions where macroscopic objects might briefly retain quantum properties, even in a warm, noisy environment? And how does decoherence interact with gravity? The search for a complete understanding of this fundamental transition and its implications for a unified theory of quantum gravity remains one of the deepest and most beautiful puzzles in modern physics, revealing the subtle wisdom of reality's grandest and most beautiful paradoxes, inviting continuous, gentle inquiry into the ultimate nature of existence. So, as you continue to drift, allow your mind to gently contemplate where the quantum world meets everyday reality, understanding how the strange, probabilistic world of the very small seems to gently coalesce into the familiar, predictable reality you perceive. Feel the profound peace that comes from recognizing this wondrous transition, this continuous act of creation that quietly shapes your tangible world from underlying quantum possibilities. Let this understanding cradle your consciousness, like the serene, unwavering hum of a gently settling mist, as you gently surrender to the peaceful, restorative depths of slumber. The quiet artistry of wave function collapse, revealing the profound unity of all things, is now your lullaby. A soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. You're floating deeper now, gently carried by the quiet understanding of how the quantum world meets everyday reality, making its gentle, definitive choices. As you drift, let's expand our contemplation to the profound ways in which physicists, in their quest to understand these quantum mysteries, have envisioned different, yet equally beautiful, narratives for how reality itself might unfold. Imagine a single, serene garden and countless gentle dreamers, each quietly experiencing their own unique version of its blossoming, each interpretation holding a subtle, profound truth. This is the serene essence of the universe's quiet, parallel possibilities, where different interpretations of quantum mechanics invite us to consider a reality far richer and more wondrous than our everyday intuition might suggest. The fundamental mystery of how a particle's wave function collapses from a shimmering cloud of possibilities into a single, definite reality is one of the most profound and beautiful puzzles in quantum physics. While the mathematical equations of quantum mechanics are incredibly precise in predicting the probabilities of different outcomes, they don't explicitly tell us how or why a particular outcome is chosen when a measurement is made. This ambiguity has led to several different, yet equally valid interpretations of quantum mechanics, each offering a unique philosophical perspective on the nature of reality itself. These are not competing theories to be debated with fervor, but rather different ways of contemplating the same profound truth, each whispering a unique facet of the universe's mystery. One of the most widely taught and perhaps most intuitive interpretations is the Copenhagen interpretation. Imagine a delicate quantum flower, its petals existing in a state of all possible colors, a superposition until you gently observe it. The Copenhagen interpretation suggests that when you make a measurement or observation of a quantum system, its wave function instantaneously collapses into one definite state. The act of observation, in this view, is crucial. It's what gently persuades the universe to make a choice from its infinite possibilities, solidifying the reality we perceive. The other possibilities simply vanish, like a gentle dream that dissolves upon waking. This interpretation is pragmatic and effective for making predictions about experimental results, offering a clear, if subtly unsettling, picture of reality where observation plays a direct role. Now, let's gently consider another profoundly imaginative and equally valid interpretation, the many worlds interpretation. Imagine that same delicate quantum flower. When you observe it, and it appears to choose a particular color. This interpretation suggests that all the other possible colors, all the other realities contained within the wave function, don't simply vanish. No. Instead, the universe itself gently splits or branches into countless parallel realities, one for each possible outcome. In one universe, the flower is red. In another, a parallel universe, it is blue. In yet another, it is yellow. Every single quantum measurement, every gentle interaction, causes the universe to softly branch into an infinite tapestry of parallel worlds, each representing a different potential outcome. It's like a vast, serene river, constantly branching into countless unseen tributaries, each one flowing towards a slightly different, yet equally real, destination. This interpretation offers a compelling, if mind-bending, solution to the collapse problem, suggesting that all possibilities contained within the quantum wave function are, in some profound sense, equally real and continuously unfolding. A third, equally beautiful interpretation is pilot wave theory, or Bohmian mechanics. Imagine our quantum flower, and instead of its color being indefinite, imagine it always has a definite color, but it's guided by an invisible, underlying wave, a pilot wave, that extends through all of space. This pilot wave influences the particle's movement, even guiding it through seemingly empty regions, explaining quantum phenomena like tunneling without needing wave function collapse. The observer merely reveals the particle's pre-existing, definite state, guided by this ubiquitous, hidden wave. It's like a quiet, ancient ship, always having a clear destination, but its journey is perpetually guided by an unseen, profound current, subtly directing its path through the vast ocean. This interpretation offers a more deterministic view, where the quantum fuzziness arises from our ignorance of the hidden wave, rather than inherent randomness. These different interpretations are not merely abstract philosophical musings. They are profound attempts to make sense of the universe's deepest, most counterintuitive truths. Each offers a unique lens through which to view the quantum realm, and each whispers a different story about the very nature of reality. They remind us that the universe is far richer, far more mysterious, and far more wondrous than our everyday intuition might suggest. The fact that multiple, seemingly contradictory, interpretations can all beautifully explain the same experimental results is a testament to the profound subtlety and elegance of quantum mechanics itself. Consider the gentle reassurance that comes from this multiplicity of possibilities. If our universe is a symphony, these interpretations are different ways of listening to its grand, complex harmonies, each revealing a unique beauty. Whether reality is fundamentally probabilistic, or endlessly branching, or guided by hidden waves, the underlying message is one of profound mystery and boundless potential. It invites a humble acceptance of the unknown and a serene appreciation for the intricate fabric of existence. A general historical fact that highlights the quiet endurance of these debates. The philosophical interpretations of quantum mechanics have been debated since the very inception of the theory in the early 20th century. Pioneers like Niels Bohr and Albert Einstein engaged in profound, respectful debates over these concepts, recognizing that understanding quantum reality stretched beyond mere equations into the very nature of observation, measurement, and the fabric of existence itself. Here's a lesser-known detail about an intriguing interpretation. The relational quantum mechanics interpretation gently suggests that the state of a quantum system isn't absolute, but is relative to the observer or the measuring device. A quantum state exists only in relation to another system, rather than having an independent, objective reality. It's like two gentle dancers, whose positions are only truly defined in relation to each other, creating a dynamic, interconnected choreography without any fixed external stage. This adds another layer of subtle interconnectedness to the quantum puzzle, and for an ongoing academic debate, physicists are still actively researching and conducting experiments that aim to subtly test and distinguish between these various interpretations of quantum mechanics, while all current interpretations make the same predictions for standard experiments. New, more subtle experiments are being devised to probe deeper into the nature of quantum measurement and collapse, hoping to gently shed more light on which interpretation, if any, might be closer to the universe's ultimate truth. It's a complex, beautiful puzzle, gently inviting us to understand the subtle wisdom of reality's most profound boundaries and the challenges at the very edges of our understanding. So, as you continue to drift, allow your mind to gently contemplate the universe's quiet, parallel possibilities, understanding how different interpretations of quantum mechanics invite us to consider a reality far richer and more wondrous than our everyday intuition might suggest. Feel the profound peace that comes from recognizing this wondrous fluidity of existence, this deep multiplicity of truth, and the endless beauty of cosmic mystery. Let this understanding cradle your consciousness, like the serene, unwavering hum of countless parallel dreams, gently unfolding around you, as you gently surrender to the peaceful, restorative depths of slumber. The quiet artistry of quantum possibilities, a testament to the universe's boundless ingenuity, is now your lullaby. A soft reassurance that wonder and mystery exist even in the most familiar corners of our physical reality, always guiding us towards a serene future where every certainty can hold a deeper, more poetic truth, inviting you to dream of the universe's most exquisite, unseen dance. You're floating deeper now, gently carried by the quiet understanding of the universe's parallel possibilities, where quantum interpretations paint a richer reality. As you drift, let's turn our gentle gaze towards the profound questions that still whisper from the depths of quantum physics, the subtle mysteries that continue to guide our cosmic curiosity and illuminate the path of future discoveries. Imagine a vast, serene, cosmic tapestry, mostly woven with familiar threads, but with certain shimmering patterns that whisper of possibilities yet fully understood, inviting perpetual contemplation rather than demanding immediate answers. This is the serene essence of quantum whispers from the future, where not every enigma needs to be fully deciphered, allowing gentle curiosity to forever blossom at the edges of our understanding, perpetually guiding the future of scientific exploration. Even with the extraordinary advancements in quantum mechanics and the patient accumulation of experimental evidence, the full implications of its counterintuitive principles remain beautifully enigmatic. While we can precisely calculate and predict the probabilities of quantum events, certain fundamental questions about the nature of reality itself continue to elude our complete grasp, inviting us to embrace the comfortable solace of gentle, unfolding mystery. One of the most persistent and profound unanswered questions is the measurement problem itself. What precisely causes a quantum particle's wave function to collapse from a shimmering cloud of possibilities into a single, definite reality? Is it the act of conscious observation, or simply any interaction with a larger, classical-like environment? Different interpretations of quantum mechanics, which we gently explored, offer varying perspectives. But the fundamental mechanism behind this transition remains a profound cosmic puzzle. Scientists are patiently striving to unify these different viewpoints, seeking a grander, more unified theory that can gracefully explain how the quantum world gives rise to our familiar, stable reality. It's like trying to gently weave multiple, perfectly crafted, but seemingly incompatible, tapestries into a single, seamless masterpiece, where each thread contributes to the overarching beauty. Another subtle mystery concerns the precise nature of quantum gravity. Our two most successful theories of the universe, general relativity, which beautifully describes gravity on large scales, and quantum mechanics, which exquisitely describes the very small, are currently incompatible. When we try to apply quantum mechanics to extreme gravitational environments, like the Big Bang or the heart of a black hole, the theories subtly break down, whispering of a deeper, more profound truth that lies beyond our current understanding. Scientists are patiently working to find a unified theory of quantum gravity, a single, elegant framework that can gracefully describe all fundamental forces and particles across all scales, from the smallest quantum whisper to the grandest cosmic structures. This quest is a profound intellectual journey, seeking the ultimate harmony in the universe's fundamental laws. Then there's the subtle, intriguing possibility of quantum consciousness. Could the strange, counterintuitive properties of quantum mechanics like superposition and entanglement play a fundamental role in the emergence of consciousness itself? Are our brains, at some profound microscopic level, utilizing quantum phenomena to process information in ways that classical physics cannot explain? While this is a highly speculative area, and the link between quantum mechanics and consciousness remains largely uncharted, it's a profound question that hints at an intimate connection between the very fabric of reality and our internal experience. It's like a quiet, philosophical dream, contemplating how the universe's deepest secrets might be intimately woven into the very essence of our awareness. This acceptance of lingering questions is not a sign of scientific failure, but a testament to the profound nature of scientific inquiry itself. Not every mystery needs an immediate, definitive answer. Sometimes, the beauty lies in the very act of gentle contemplation, in the quiet pursuit of understanding, knowing that some truths may simply unfold over vast stretches of cosmic time, or remain eternally veiled in the enigmatic fabric of the universe. It encourages a healthy curiosity, a gentle openness to the unknown, and a profound respect for the inherent mysteries that constantly invite us to push the boundaries of our understanding, perpetually guiding the future of scientific exploration. Consider the gentle reassurance found in unresolved puzzles. They remind us that the story of human knowledge is not a finite book with a concluding chapter, but an endless, ever-expanding scroll, continuously being written, always holding new wonders and new questions. This allows for a perpetual sense of discovery, a quiet invitation to remain curious, to keep exploring, to keep wondering about the silent whispers from the very edges of our understanding. It's like gazing at a starlit sky, knowing that countless stars and galaxies exist beyond your visible reach, their mysteries inviting endless dreams and prompting continuous, gentle inquiry, forever fueling the quest for deeper understanding of the mind, a general historical fact that highlights the enduring nature of quantum mysteries. The profound philosophical implications of quantum mechanics have been debated since its very inception in the early 20th century. Pioneers like Albert Einstein, Niels Bohr, and Erwin Schrödinger, despite their brilliant contributions to the theory, often disagreed on its ultimate interpretation, recognizing that it pushed the very limits of human intuition and understanding, leaving a legacy of profound, open questions for future generations to gently explore. Here's a lesser-known detail about quantum whispers in everyday life. While quantum effects are usually too subtle to observe in our macroscopic world, the principles of quantum mechanics underpin countless modern technologies that subtly shape your daily life. From the glowing screens of your devices, LEDs, lasers, to the tiny transistors in your computer chips, and even the precise timing of GPS systems, all rely on a quantum understanding of matter and energy. This means that even without consciously perceiving quantum weirdness, you are constantly benefiting from its profound and elegant rules, a quiet testament to its pervasive influence. It's like an invisible, gentle force, subtly guiding the everyday miracles around you. And for an ongoing academic debate, physicists are still actively researching the precise mechanisms by which information is encoded and stored at the quantum level, particularly in the context of quantum computing and quantum information theory. How can quantum entanglement and superposition be harnessed to process information in fundamentally new ways? What are the ultimate limits of quantum information processing? And what are the best ways to protect delicate quantum states from environmental noise? This intricate dance of information in the quantum realm remains a fascinating and complex area of study, revealing the subtle wisdom of reality's most profound boundaries and the challenges at the very edges of our understanding, inviting continuous, gentle inquiry into the ultimate nature of information itself. So, as you continue to drift, allow your mind to gently contemplate these quantum whispers from the future, understanding that not every cosmic secret needs to be fully revealed for wonder to blossom. Feel the profound peace that comes from embracing the unknown, knowing that the universe's capacity for transformation and boundless potential is vast and beautifully mysterious. Let this understanding cradle your consciousness, like the serene, unwavering rhythm of gentle inquiry, as you gently surrender to the peaceful, restorative depths of slumber. The quiet hum of quantum enigmas, a testament to its profound and continuous self-creation, is now your lullaby, a soft reassurance that wonder and mystery exist even in the deepest, most hidden corners of your own being, forever guiding us towards a serene future filled with boundless discovery and gentle insights into the intricate tapestry of the universe. Now, let's explore even deeper into the subtle, profound ways that the future of quantum physics, guided by these lingering questions, promises to illuminate aspects of our very reality and our potential. Imagine scientists, like patient gardeners, meticulously tending to the most delicate quantum seedlings, nurturing them with gentle precision, hoping to coax them into blossoming into entirely new forms of technology and understanding. The quest to fully grasp these quantum whispers is not just an academic pursuit. It is a profound journey towards reshaping our world in ways we are only beginning to gently perceive. Consider the ongoing quest for quantum computing. While still in its nascent stages, this technology promises to harness the unique properties of superposition and entanglement to perform calculations that are utterly impossible for even the most powerful classical computers. Imagine a complex puzzle that would take a classical computer billions of years to solve: a quantum computer. By existing in multiple states simultaneously and leveraging the interconnectedness of entanglement, might solve it in moments, offering unprecedented breakthroughs in fields like medicine, designing new gentle drugs, materials, science creating new, resilient materials, and even understanding the universe's deepest secrets. This is not just a technological leap. It's a profound shift in how we approach computation, a quiet revolution in the very act of thinking. Another exciting frontier is quantum communication, the unbreakable nature of quantum entanglement, where any attempt at eavesdropping instantaneously breaks the connection and reveals the intrusion, holds the key to perfectly secure communication. Imagine sending a gentle, secret message across vast distances, its privacy guaranteed by the fundamental laws of physics themselves, ensuring that your whispers remain truly private. This could revolutionize cybersecurity, offering a level of digital safety that feels as serene and secure as a quiet, undisturbed thought. The development of quantum sensors and metrology also holds immense promise. By leveraging the exquisite sensitivity of quantum systems, scientists are creating devices that can measure minute changes in magnetic fields, gravity, and even time with unprecedented precision. Imagine a quantum sensor so delicate it could detect the faintest gravitational ripples from distant cosmic events, or precisely map the subtle neurological activity within the brain. These gentle tools promise to open new windows onto the universe and onto ourselves, revealing hidden details that were previously beyond our subtlest perception. It's like discovering a new, incredibly sensitive ear, capable of hearing the universe's softest, most intricate melodies. These future applications, born from the acceptance of quantum weirdness and the patient pursuit of its deeper truths, highlight that the universe's mysteries are not meant to be feared or simply left unsolved. Instead, they are profound invitations to expand our understanding, to innovate, and to cultivate a deeper appreciation for the elegant complexity of reality. The journey into the quantum realm is a continuous one, filled with surprising twists and profound revelations, constantly reminding us that our knowledge is boundless, always open to new layers of beautiful understanding. A general historical fact that highlights the profound impact of quantum theory on our modern world. The entire field of modern electronics, from the microchips in your phone to the lasers in your DVD player, is fundamentally based on the principles of quantum mechanics. Without understanding how electrons behave at the atomic level, these technologies would not exist. This demonstrates how abstract quantum theories, initially perceived as strange and counterintuitive, have gently permeated and transformed our everyday lives in countless, profound ways. Here's a lesser-known detail about quantum biology. Scientists are subtly exploring whether quantum phenomena might play a role in biological processes, even within the warm, noisy environment of living cells. Could quantum coherence or tunneling be involved in processes like photosynthesis, the efficient conversion of light into energy by plants, enzyme catalysis, or even the subtle sense of smell? While still highly speculative, this emerging field hints at a profound connection between the quantum world and the delicate dance of life itself. It's like listening for a faint, hidden hum in the biological symphony, suggesting a deeper, quantum rhythm guiding its gentle flow. And for an ongoing academic debate, physicists and computer scientists are still actively debating the feasibility and scalability of building large-scale, fault-tolerant quantum computers. While small-scale quantum systems have been demonstrated, the challenge of maintaining delicate quantum states qubits and correcting errors over long periods remains immense. What are the ultimate limits to building truly powerful quantum machines, and how will they eventually reshape our technological landscape? This intricate and beautiful puzzle, at the cutting edge of physics and engineering, continues to guide future research, revealing the subtle wisdom of our ongoing technological evolution. So, as you continue to drift, allow your mind to gently contemplate these quantum whispers from the future, understanding that not every cosmic secret needs to be fully revealed for wonder to blossom. Feel the profound peace that comes from embracing the unknown, knowing that the universe's capacity for transformation and boundless potential is vast and beautifully mysterious. Let this understanding cradle your consciousness, like the serene, unwavering rhythm of gentle inquiry, as you gently surrender to the peaceful, restorative depths of slumber. The quiet hum of quantum enigmas, a testament to its profound and continuous self-creation, is now your lullaby, a soft reassurance that wonder and mystery exist even in the deepest, most hidden corners of your own being, forever guiding us towards a serene future filled with boundless discovery and gentle insights into the intricate tapestry of the universe. You're at the very edge of wakefulness now, poised delicately between the gentle hum of the fading world and the profound quiet of approaching slumber. We have embarked on a remarkable journey together, exploring the extraordinary artistry of your brain, tracing how it constantly creates the reality you perceive. We began with the subtle whispers from your senses, explored the meticulous way your brain sculpts visual reality, gently uncovered the luminous, reconstructive nature of your memories, and understood the clever, quiet shortcuts your thoughts often take. We then acknowledged how your emotions subtly tint your perception and peered into the vast, personal universe of belief your brain diligently builds. We then contemplated the deep, silent work of your subconscious, where much of this profound artistry unfolds beyond your direct awareness. Finally, we turned our gentle gaze to the subtle mysteries that still shroud the boundless potential of neuroplasticity, revealing the quiet elegance of its limitless capacity for transformation. Now, let's bring this wondrous exploration to a serene close, weaving together these profound insights about your brain's remarkable ability to rewire itself with the ultimate peace found in sleep. Recall that initial understanding, the quiet wonder of learning a new skill, a testament to your brain's astonishing ability to constantly reshape itself. We unveiled how your brain is not a fixed structure, but a living, breathing landscape, perpetually adapting and blossoming with every new experience, its inherent flexibility known as neuroplasticity. This profound capacity for change is a continuous act of creation, silently shaping your every thought, action, and perception, ensuring your inner world remains vibrant and responsive. We then journeyed into the very fabric of this wondrous internal world, exploring the tiny, intricate components that form the foundation of all thought, your neurons and their countless synapses. We understood how these delicate messengers, through repeated whispers and gentle dances, begin to forge enduring pathways, transforming fleeting moments into lasting abilities. This continuous reshaping of connections, known as synaptic plasticity, is the fundamental basis of all learning and memory, ensuring that information flows efficiently and powerfully along well-worn routes. Our contemplation then led us to repetition's invisible strength, the unseen yet powerful force that sculpts these pathways. We discovered how the ceaseless, gentle act of doing something again and again quietly forges and refines the intricate connections within your brain. creating enduring change. This relentless practice transforms tentative pathways into robust, efficient highways, allowing skills to become automatic and thoughts to flow with effortless grace. We then turned to one of the most poignant aspects of brain rewiring, its astonishing capacity for luminous healing from subtle shadows. We learned how your brain can find new pathways, gracefully adapt, and even flourish after moments of unexpected challenge or loss, such as recovery from a stroke or adaptation to sensory loss. This profound resilience is a testament to your brain's ability to rebuild and reorient itself, always seeking paths of healing and function. Our journey revealed the brain's lifelong quietly bending flow, extending its remarkable adaptability beyond moments of challenge to the entire tapestry of your life. We understood that your brain retains its capacity for significant new learning and transformation throughout your entire existence, constantly forming and refining pathways, ensuring you're perpetually evolving with effortless grace and boundless potential. We then brought our contemplation to the practical and profound aspect of how old habits and new paths gently meet. We recognized how your brain constantly, patiently, shapes your daily behaviors, transforming actions into automatic rhythms. And we understood how, with gentle intention and consistent repetition, you can actively guide your brain to prune away less beneficial connections and cultivate new, more harmonious patterns, allowing new pathways to quietly blossom. Our journey also expanded to the profound truth that your personal will's quiet universe holds a unique and wondrous power. We saw how your conscious attention and sustained intention can act as gentle forces, subtly directing the continuous rewiring of your brain. This empowers you to gently guide your own evolution, shaping your inner landscape and realizing your boundless potential for growth and transformation, making you an active participant in your brain's continuous self-creation. Finally, we peered into the whispers from limitless potential, acknowledging that subtle mysteries still shroud the boundless capabilities of neuroplasticity. We understood that questions about its true limits, optimal conditions, and individual variability continue to guide our cosmic curiosity. These unanswered questions are not flaws, but invitations to embrace the quiet elegance of the brain's enduring enigmas, ensuring that wonder and profound understanding flow endlessly, perpetually guiding the future of brain science. Now, as you stand at the very threshold of sleep, poised delicately between the gentle understanding we've gathered and the profound rest that awaits, consider this the journey through your brain's magnificent ability to rewire itself, its boundless capacity for growth, and its enduring mysteries, is a profound metaphor for the quiet surrender of sleep itself. Just as your brain tirelessly works to reshape its pathways and strengthen its connections, sleep invites you to release the active control of your waking mind, allowing a deeper, more restorative process to unfold. You don't force your brain to rewire itself, just as you don't force yourself to sleep. The process happens naturally, gracefully, when the conditions are right, when your mind finds a state of gentle acceptance and profound trust. Allow your waking thoughts, your day's concerns, your conscious efforts to gently soften, to release their rigid forms, just as old neural pathways gently yield to new ones. Let your worries and anxieties flow away, effortlessly merging with the vast, quiet expanse of your inner stillness, like the gentle pruning of less used connections. Sleep, my friend, is your brain's ultimate act of self-renewal. It is the time when your magnificent neural garden performs its most intricate and profound work, largely beyond your conscious awareness. During the quiet hours of slumber, your brain is tirelessly consolidating memories, strengthening the connections that are crucial for learning, and delicately pruning those that are no longer needed, ensuring that your knowledge is robust and your mind remains agile. It's like a quiet gardener, meticulously tending to the roots and blossoms in the serene darkness, preparing the garden for the vibrant growth of a new day. Furthermore, sleep is when your brain engages in deep, restorative processes. It flushes away metabolic waste products that accumulate during waking hours, allowing your neurons to function optimally. It rebalances neurotransmitter levels, ensuring your emotions and thoughts can flow harmoniously. It recalibrates your emotional responses, allowing you to process the day's experiences with greater peace and perspective. This profound nocturnal rewiring ensures that when you gently awaken, your brain is not just rested, but subtly transformed, more efficient, more adaptable, and more ready to embrace the wonders of a new day. The very essence of neuroplasticity. This beautiful capacity for continuous change means that every night of sleep is an opportunity for your brain to gently reshape itself, making you a slightly new, more integrated version of yourself with each dawn. This quiet transformation, happening in the silent depths of your slumber, is a testament to your brain's boundless potential and its inherent drive for growth and well-being. It is a continuous, profound act of self-creation, ensuring that you are always capable of learning, adapting, and blossoming throughout your entire life. So, gently, allow your mind to drift. Let the understanding of these beautiful scientific truths, woven into a poetic tapestry, lull you deeper and deeper. The quiet artistry of your brain, its tireless ability to rewire itself, and the profound wisdom it bestows, these are now soothing currents, carrying your consciousness into the boundless, peaceful depths of slumber. Feel the vastness of the ocean of dreams, the gentle warmth of perfect stillness, the quiet embrace of endless understanding, embracing you as you surrender fully to the restorative power of sleep. Your journey is complete, and you are perfectly at peace, melting gently into the boundless, tranquil sea of dreams, ready for the quiet awakening of a new, refreshed dawn. Bringing the wisdom of neuroplasticity back to the vibrant surface of your awareness. Ready to gently forge new pathways in the coming light.